Okay, so total we have 24 problems. So I'll try to give you at least some idea about each and every problems. Okay. So, and your exam will cover from chapter 4 to 7. So the first problem is from chapter 4, and this is about continuous random variable and PDF function and finding the probability from continuous random variable. The first, the given function here, f of x, is a PDF function, and the support or values of x, corresponding values of x are from -2 to 2. So the first question is discuss the graph of f of x. So you have to find the graph of f of x. So there are several steps to follow to find the graph. So first you can check instead of constructing the graph of the function, actual graph of the function, you can just check which graph is the correct graph for the given function. So how can we check? So the values for x are -2 to 2. So first you have to check whether the graph is from -2 to 2. Yeah, for the first one, -2 to 2. And for the second one, it's also -2 to 2. And for the third one, it's also, so all the graphs are from -2 to 2. But we have to find the correct graph. So how can we find the correct graph? So at 0, or you can check the value of f of x at 0, because you can see here the values for each graph are different for x equals to 0. So you can check the value of f of x at x equals to 0. So if you plug in x equals to 0, then it will be 0.09374 times 4. So at x equals to 0, it will be 0.09375 times 4. So if you find that value, then you will see that that value will match with the second graph, with this one, with this graph. So the correct answer will be this one. Okay, the next problem is, the next part is compute the probability x greater than 0. So one way is you have the PDF function, so you can integrate the PDF function from 0 to 2, or you can just look at the graph. So the 0 is in the middle, and the graph is symmetric, right? If you look at the graph, you can see it is symmetric. So the distribution is symmetric. So that's mean uh, the left side, the area on the left side of the middle value is the 50% of the total area. So the 0 is the middle value. If you look at the graph, then you will see that the 0 is the middle value. So on the right side of 0, the area will be also 50%. So the probability is 0.5. So you do not need to calculate this one. You can just directly write is 0.5. So now you have to compute the probability from -1 to 1. Here you cannot directly find the answer. So you have to integrate from -1 to, for part C, you have to integrate -1 to 1 f of x dx. The lower limit is -1 and the upper limit is 1. So you have, and both of the values are between -2 and 2. So that's mean you have to integrate the f of x function from -1 to 1. And f of x is 0.9375. So this is -1 to 1, 0.09375 times 4 minus x squared dx. Now we have to integrate this one. So if you integrate this one, then you will get 0.9375, and this is 4x minus x cubed by 3, and x is from -1 to 1. Okay, now we have to plug in all this number. For first you have to plug in x equals to 1, then minus, plug in x equals to -1, and you will get the, if you simplify that one, then the value will be 0.6875. And similarly for part D, you have to integrate from, sorry, for part B, the probability x less than -1.1 and or x greater than 1.1. Yeah, so in this case, what you have to do, for part D, it will be or, so that's mean you have to add this to probability, because you have probability of x less than -1.1 or x greater than 1.1. So for the first part, x less than -1.1, the probability will be -2 to the upper limit is -1.1 f of x dx, plus for the second part it will be x greater than 1.1, so that's mean 1.1 to 2 f of x dx. And we already integrated f of x here, so you will just plug in the numbers -2, -1.1, and you will simplify this one, then you will get the probability of x less than -1.1, and this probability is 0.2582. Okay, the second question is, we are given a function and a college professor never finishes his lecture before the end of the hour and always finishes his lectures within 2 minutes after the hour. So the professor finishes the lecture within 2 minutes after the hours. After the end of, so let x be the random variable, and this is the time that elapses between the end of hour. So at the end of hour, the value of x is 0, and the end of the lecture, and so at the end of the lecture, so end of the hour, the x is 0, and the end of the lecture, x will be 2, because the professor finishes the lecture within 2 minutes. So that's mean the possible values for x will be, x is 0 to 2. And we are given a function f of x is equals to kx squared, where x is from 0 to 2. And it is given that this is a probability density function. So we know the properties of probability density function. So here the value of k is unknown. So we have to find the value of k. So what do we know about probability density function? We know that -infinity to infinity f of x dx is equal 1. This is the total probability, right? The total probability is 1. So our function is kx squared dx, which is 1. So now the value of -infinity, that's mean lower limit of x is 0, and positive infinity, that's mean the upper limit of x is 2. We have to integrate this one. So if you integrate this one, then it will be k x cubed over 3, and x is from 0 to 2 is equal 1. Now plug in the value of x, so then it will be k 1 cube, that's mean 1 over 3. Oh, sorry, the value of x is 2, so 2 cube over 3, and minus the value of x is 0, the lower limit, lower limit is 0. So if you plug in 0, it will be 0 is equal 1. So that's mean k times 8 over 3 is equal 1. So that's mean k is equal 3 over 8. So the value of k is 3 over 8, which is 0.375. Now we have the value of k, then the function will be f of x is equal 3 over 8 x squared. So this is the density function, and x is from 0 to 2. So now we have to find the graph for this function. So to find the graph for this function, first the function is this one, and x is from 0 to 2. So you have to look at the graph where x is 0 to 2. I think its graph is from 0 to 2. Now this is x squared, So the shape of the function will be like this. But we have from 0 to 2, so that's mean the shape of the function will be like this. So now, so this is not the correct function because this is just a straight line. So it cannot be the correct function because the shape of the function will be like this. This is parabola. So how about this one? We can check the value of f of x at different value of x. At 0, it will be 0, that's fine. But at 1, x equals to, when x equals to 1, it will be 3 over 8. But I don't think that this is 3 over 8. This is 0. It is not 0.375. So this is not also correct. So now we have to check the rest of the two graphs. So this is not also correct because it should be, the shape of the graph is parabola. So this is not also correct. This is not correct. This is not the correct graph. The correct answer will be this one then. Yeah. Okay, in part B, what is the probability that the lecture ends within 1 minute of the end of the hours? So we have to find the probability where x is from. That's mean we have to find the probability within 1 minute. So that's mean x less than equal 1. Probability of x less than equal 1. And this is equal negative infinity to 1 f of x dx. And the lower limit is 0. So it will be 0 to 1. And f of x is 0.375 x squared. So it will be okay. So f of x is, this one will be 0 to 1. F of x is 0.375 x squared dx. So now we need to integrate this one and plug in the values of x and simplify. Then you will find 0.125. And similarly for part C, what is the probability that the lecture continues beyond the hour of for between 30 to 75 seconds? So here the time is in seconds, but in our distribution function, the time was given in minutes. So first you need to convert the second into minute. So 30 minutes means 30 divided by 60. So this is 0.5 minutes. And this one will be 75 over 60. So it will be 1.25 minutes. That's mean we have to integrate f of x from 0.5 to 1.25 f of x dx. And for part B, what is the probability that the lecture continues for at least 105 seconds beyond the end of the hour? So 105 seconds. First, you need to convert this one into minute. So it will be then 105 over 60 minutes. Then you will integrate from 0 to this number, f of x dx. And you will get the probability is 0.3301. And for part C, the probability is 0.2285. Do you have any question? Okay, the next problem is we are given a CDF function. Let x denote the amount of time a book on 2-hour reserve is actually checked out. And suppose the CDF function. So x is the amount of time, and we are given a CDF function. Here x is the amount of time. So this is continuous random variable, and we are given a CDF function. So this is the CDF function. So now we will use the CDF function to obtain the following probability. So we have to calculate the probability x less than equal to, and we know that this is just f of 2. we have the f, capital F function. So f of 2 means, and you have to check where the number 2 is. So here x is less than 0, so 2 is not here. Here x is 0 to 5, so 2 is between 0 to 5. And for 0 to 5, the function is x squared over 25. So we have to plug in this number in this function. So 2 squared over 25, it will be 4 over 25. This is 0 0.16. The second problem is we have to calculate the probability from 1.5 to 2. So in this problem, we have to find probability 1.5 x less than equal to. So this is just f of 2 minus f of 1.5. And the part C is, this is part B. Part C is probability x greater than 2.5. So it will be then, we have to use the CDF function. So for this symbol, we do not have the CDF function, right? X greater than 2.5. The CDF always give you the probability when x is less than equal some number. So what we can do, we can take the complement of this one. This is just 1 minus probability of x less than equal to 2.5. This is 1 minus f of 2.5. Okay, any question? Okay, can I erase it? Okay. So someone asked whether since this class will be reviewed. Yes, I'm going to take the attendance. Part D is, what is the median checkout duration? So we have to find the mu tilde. That means we have to find the median. For median, we know that at median, the CDF is, the probability is on the left side of the median, the probability is 0.5, right? If mu tilde is the median value, then on the left side of mu tilde, the probability is 0.5. So we have to find the value of x, for which f of x is 0.5. That's mean x squared divided by 25 is 0.5. So x squared is equals to 0.5 times 25. So it will be, I think x squared equals to 12.5. So x will be just a square root of this number. Actually, we'll have two values here. One is positive, the other one will be negative. But we have to consider the positive value. We cannot consider the negative value because x is positive here. If you look at this number, x is always positive, 0 to 5. So the median will be for sure in between 0 to 5. So we have to just take the square root of this. So x will be a square root of 12.5, which is 3.5355. So in part E, we have to find the density function f of x, and which is equal f prime x. So f prime x means d dx f of x. So it will be d dx x square over 25. So it will be 2x over 25, and x is from 0 to 5. X is from 0 to 5. So you have to also mention the value of x, because for the other values of x, f of x is 0. Now you can see here the f of x is 2 over 25x, and otherwise it will be 0. Okay, part F is we have to find the expected value. So the definition of the expected value is part F, expected value of x is negative infinity to infinity x f of x dx. But f of x is defined for 0 to x equals to 0 to 5. So the lower limit is 0, upper limit is 5, x, and f of x is 2 over 25 x dx. So it will be then 0 to 5, 2 over 25 x squared dx. If you integrate this one, then it will be 2 over 25 x cube over 3, x is from 0 to 5. Now just plug in 5 for x, and that will be the expected value. So the expected value is 3.3333. So this is the expected value of x. Now we have to calculate the variance of x. So per z is calculate variance of x. This is equal expected value of x square minus expected value of x whole square. So we already have the expected value of x from here. Now you need to just calculate expected value of x squared. So the expected value of x squared is equal 0 to 5 x squared 2 over 25 x dx. So you need to just integrate this one and simplify, then you will get a number, and then subtract this number from that number, and that will be the variance, which is 1.3889. And standard deviation is the square root of the variance. So this number is the square root of 1.3889, the square root of this one. The last part is we have to find the expected value of a function of x. Okay, so I am erasing everything. The last one is part 8, expected value of h of x. That's mean expected value of x squared. And we already have this value from the previous part, right? So we already calculated this one. We already calculated this one to calculate the variance of x. So you can just plug in that number, which is 12.5. The expected value of x squared is 12.5. Okay, number 4, we are also given the CDF function. So that CDF function f of x is half plus 3 over 68 times 7x minus x cubed over 3. And this function is defined for x equals to x from negative 2 to 2. So the subroot is negative 2 to 2. And for the other values of x, the PDF is 0. And when x is less than negative 2, the CDF is 0. And when x is greater than equal to, the CDF is 1. Now we have to compute the probability where x is less than 0. So part A, we have to find probability x less than 0. So this is just f of 0. So that's we have plus 3 over 68, 7 times 0 minus 0 cube over 3. So this will be just half. So this is 0.5. So for probability x less than 0, this is 0.5. Compute the probability when x is between -1 and 1. Yeah, most probably the distribution is symmetric, because at x equals when probability of x less than 0, the probability is 0.5. So that's mean the median is in the middle. So most probably the distribution is symmetric. So part B is -1 to 1. Probability of -1 x 1. So this is just f of 1 minus f of -1. So you will just plug in this number here in this function and simplify it, then you will find 0.5882. And part C is probability where 1.1, that's mean x greater than 1.1. So that's mean x greater than 1.1. So which can be written as 1 minus probability of x less than equal 1.1. Because CDF always give you the probability where x is less than equal some number. So this is just, sorry, this is just sorry. Yeah, so we are doing C. This is probability 1.1 less than x. So that's been probability of x greater than 1.1. So that's been 1 minus probability of x less than equal 1.1. So 1 minus f of 1.1. So you'll plug in this number in f of x and simplify it, then you will find this is 0.1799. Now in part D, we have to find f of x, which is the derivative of the capital F. So if you calculate the derivative of this one, then it will be the derivative of this part is 0, and the derivative of this part will be then 3 over 68, 7 minus 3x squared over 3. So 3 will be cancelled out. So we'll have 3 over 68 times 7 minus x squared. So if you factor out minus sign, then the answer will be this one. Yeah, so this is the final answer. Now you have to compute mu tilde, the median value. So that's mean in part E, we'll consider f of x is equals to 0.5. So what is the value of x in this case? Can anyone tell me? What is the value of x? So what is the value of x in this case? Anyone? Yes, it is 0. Now, f of x is 0.5. You have to find the value of x. Actually, you do not need to calculate it, right? Because you already have this one. You already calculated this one. Probability of x less than 0, that's with f of 0, and you found this is 0.5. So now per party we are considering f of x equals to 0.5. So we already found that this value is 0.5. So that's mean x is equal 0. So in part A, we already have the result, right? In part A. Or you can just consider f of x equals to 0.5. So that's means this one is equals to 0.5 and simplify and find the value of x. But you do not need to do that because you already have the value for the median. So you do not need to calculate it. Okay. Okay, so number 5. I think I do not need to go over this one. You can, do you want me to go over this one? Or you can do it by yourself. This is just finding the probabilities by using calculator, or you can also use the Z table. Yeah. Do you want me to go over this one? Or I should skip this one? Yeah. 2 means part B. Yeah, number 2 means part B. Okay, so just two examples. Okay, so you are saying, okay, so on problem pipe. Okay, yeah, sure. Yeah. We can just, yeah, I got it. Yeah. Okay, so in part A, we have to find probability less than equal Z less than equal 2.23. So this is actually probability between 0 and 2.23. So let's pull up the probability table, Z table, and here it is here. Let me, yes. So this is the Z table. So we have to find the probability between 0 and 2.23. Yeah, so this is the Z table. So we have to find the probability between 0 and 2.23. So if you want to, I'll recommend you to use the calculator because it's easier. But if you want to use the Z table, then probability between okay, so we are looking for probability between 0 and 2.23. So that's mean first you have to look at this number, then find the probability. So Z is 2.23. These values are Z and these values are Z. And the value inside the chart, these values are the area or the probability. So this is the Z score. The first one is 0.0. This is also 0. So that's mean this is the probability for 0. So when Z is equals to 0, the probability is 0.5. But first we'll find the probability for 2.23. So first look at the value for Z where Z is 2.23. Here Z is 2.2 and the second digit is 3. So the second digit is on the top row. So here this is 3. So 2.2 is here. So we should go up to here and this is 3. So that's mean the probability is this one, 0.9871. So the probability for 2.23 is 0.9871 minus the probability for Z is equals to 0. So Z is 0 is, this is 0, this is 0. So that's this probability. So minus 0.5. So that will be then 0.4 I think 0.4871 maybe. Or you can just subtract this one and you can check. Okay. So similarly for example, if you want to find the probability between 0.1 and 2.82. So first you will find the probability for 2.82. So look at the value of z, where this is 2.8 and 0.2 is, this is 2.8 and second digit is 2. So that's with this one. So 2.8 is here and 0.2 is here. So this probability is for 2.82 and minus the probability for 0.1. 0.1 is here. So that's mean this probability minus this probability. So it will be then 0.99. So it will be then point. Now let me check the probability. Yeah, so it will be then 0.9976 minus 0.5398. So it will be then 0.9976 minus 0.5398. Okay, so let me share the lecture. So similarly, you can find the probability for this one. You can find the probability for rest of the problems. I'll recommend you to use the calculator. Okay, so but I need to explain the last one. Yeah, because last one is a little different from the other problems. So the last one is probability of absolute value of z less than equal 2.50. So this is actually probability of, if you have absolute value, so that's mean absolute value means this is between negative a and a. So here this is 2.50. So that means z is between negative 2.5 to 2.5. Yeah, now you can find the probability, right? So first you need to write this one in this form, and now you can use the z table or you can use calculator to find the probability. Okay. So problem 6, determine z alpha from for the following alpha. So that means you are given the probability, you have to find the z score. So here alpha is 0.0056. So you have to find the z alpha. Okay, so but here you need to remember, if you have z alpha, that's mean you are looking for the z score where z is on the right tail. So that's mean you are looking for this value, this z alpha, where this area is alpha. But if you have negative z alpha, so that's mean you are looking for the z score where the area is on the left side. So this is negative z alpha. Okay. Yeah, so for the first one, the alpha is 0.0056. So that's mean this area is 0.0056. Now you have to find the z score. So if you look at the z table, and this is the area, so if you look at this area, you will get a negative number. if you look at 0.0056, you will get a negative number. But the Z alpha is on the right tail, so it should be positive. So you will just take the same number with positive sign. So you will just ignore the negative sign. So in the table, you can just look at this area 0.0056, or other way, you can just do 1 minus 0.0056. And if you look at this area in the table, then you will directly get this number, Z alpha. So you can do either of the both way. So one way is you can subtract this number from 1 and look at the table, you will directly get this number. Or you can just look at this number and you will get a negative number, but ignore the negative sign. Just consider the positive number. Then you will get this Z alpha. Okay. So this will be 2.54. So in the table, if you just directly look at this number and find the Z corresponding Z value, then take the value with opposite sign. So if you get negative number, then consider a positive number. If you get a positive number, then consider it as negative. Is it clear? So for Z alpha, if you look at the table, if you look at directly at this area, then always consider the Z score with opposite sign. Whatever Z score you get from the table, consider the Z score with opposite sign. Okay. Do you have any question? Because you also need this idea in hypothesis test chapter, but hypothesis test is not is not in your syllabus for the second exam. Do you have any question? Okay, so problem 7 is also similar to the previous one, but the only difference is in the previous problem we had the Z score and we directly calculated the probability. And here the only difference is you have the value of X, but you do not have the value of Z, and you have to find the probability. So this is actually similar problem, but here you need to do some work. So for part A, this is probability X less than equal 13. So first you need to convert this number to Z score. So we have 13 here. So convert 13 first as Z score, and you know the formula, which is X minus mu over sigma. So X minus mu over sigma. Mu is the mean, sigma is the standard deviation. So here we are given the mean is 13, standard deviation is 1.5. So if you want to convert 13, then it will be 13 minus, the mean is 13 and standard deviation is 1.5. So this is the 0. So the first one is actually you are looking for probability where Z is less than 0. Or you can write probability Z less than 0 instead of this one. They are actually same. Both of them are same. But to find the probability, you always need to convert it to standard normal distribution. So that's why we are converting X to standard normal distribution. So for part B, first you need to convert 14.5 into Z score. So it will be then 14.5 minus 13 divided by 1.5. So it will be then 1.5 divided by 1.5. So that's been 1. So this is actually equivalent to Z less than equal 1. So they are also similar to the previous problems. The only difference is here you have the X values, you need to convert it to Z score. Okay, so I'm just only going to show you this part because this part is little tricky. Okay, so part A is probability of absolute value of X minus 13 less than equal 1. So we can just write -1 x minus 13 to positive 1. So when you have absolute value of x is less than some number, so that's mean x is between -1 to 1. But here we have absolute value of x minus 13 is less than 1. So that's mean x minus 13 is between -1 to 1. So now you need to simplify this one. You need to find the value of x. So we have to add 13 with its number, because we want to isolate x. So it will be then 12 and it will be 14. So that's it. We are looking for the probability where x is between 12 and 14. Do you have any question? Is it clear?
Yes, sir.
Okay, thank you. So the next problem is number 8, where x is the time between two successive arrivals at the drive-up window of a local bank. If x has an exponential distribution, even if it was not given, the distribution was not directly given, you should know the distribution, because this is the time between two successive arrivals. So this is kind of waiting time distribution, and this is continuous, so it should be exponential. So we discussed actually different type of distribution: exponential, we discussed gamma, we discussed Poisson. Poisson is the discrete. So Poisson and exponential is waiting time distribution. So if the waiting time distribution is discrete, so you should consider as Poisson, because we only discuss the Poisson distribution as waiting time distribution where the random variable is discrete. And if the waiting time distribution is continuous, in our case, then it will be exponential, because we only discussed two distributions which is related to waiting time. Okay, so x is exponential distribution and the parameter lambda is 1. So we know the PDF function for the exponential distribution. So do you remember the PDF function for the exponential distribution? Okay, so you do not need to remember it, because the distribution will be given. So this is lambda e to the power minus lambda x. And your exam is open book, open note, so you can look at your note or you can look at the book to get the distribution. So and x is greater than 0. So this is the PDF function for exponential distribution. So what is the mean mu? Yeah, you should know this one. What is the mean mu in this case? And what is the variance sigma squared? Can anyone tell me the mean and variance for exponential distribution? Do you remember? The mean for the exponential distribution and variance for the exponential distribution. What is the mean of the Poisson distribution? Okay, can anyone tell me the mean of the exponential and the variance of the exponential distribution? If lambda is the parameter. Okay, that's fine. Mean is 1 over lambda and variance is 1 over lambda square. Okay, so now tell me, what is the standard deviation? What is the standard? Yeah, you should know this standard deviation, because we already know the variance. So you can find the standard deviation sigma. So what is the standard deviation for exponential distribution? Yes, square root of 1 over lambda square, square root of variance. Yeah, you're right. Yeah, it is 1 over lambda. Correct. So this is 1 over lambda. Yeah. Okay. The first question is the expected time between two successive arrivals. So what is the expected time then? Expected time is the mean, right? So what is the mean in this case? This is just 1, right? 1 over lambda, that's mean 1 over 1. So the mean is 1. So what is the standard deviation? Standard deviation and mean are same. So this is also 1. So now we have to find the probability x less than equal to. So how can we find this probability? Probability of, so part C is x less than equal to. So since lambda is 1, so in our case, the distribution will be then just e to the power minus x, x greater than 0, because lambda is 1. So it will be then 0 to 2 e to the power minus x dx. So this is the probability. So if you integrate this one, then it will be negative e to the power minus x, and x is from 0 to 2. So it will be then negative e to the power minus 2 minus e to the power minus 0. So it will be then minus e to the power minus 2, and this is negative, so it will be plus e to the power 0 is 1. So it will be negative e to the power minus 2 plus 1. So the probability is 0.865. So this probability is 0.865. Okay, part D. So we have to find the probability where x is between 1 and 4. So this is 1 to 4 f of x dx. So that's been 1 to 4 e to the power minus x dx. So this is equal negative e to the power negative x, and x is 1 to 4. So this is equal negative e to the power minus 4 minus negative e to the power minus 1. So that's been minus e to the power minus 4. This is negative, so it will be plus e to the power minus 1. So if you simplify this one by using calculator, then it will be 0.350. This is the answer. Okay, so I am erasing everything. Number 9 is data collected at an airport suggests that an exponential distribution with mean value. So we are given this is also exponential distribution with mean mu is 2.675. So here mean mu is 2.675. So mu is 2.675. So we can find the lambda. Lambda will be then 1 over mu. So 1 over 2.675. So this is the lambda value. In part A, what is the probability that duration of a particular rainfall event at this location is at least 2 hours? At least 2 hours means part A, at least 2 hours means x less than 2. Because x is the duration of the rainfall. and the value of x is from 0 to infinity. So at least, okay, actually I did wrong. This is at most 2, x less than 2. So how can we write at least 2? X cannot be less than 2, right? So that's when x greater than equal 2. So this can be written as 1 minus probability of x less than 2. So 1 minus, and this probability we know that 0 to 2 f of x dx. So what is f of x in this case? F of x is equals to lambda times e to the power minus lambda x. And this is the lambda value. So this is our lambda. So you can just plug in this number here, and that will be the lambda value. Okay, the next one is at most 3. So that's mean probability of x can be maximum 3. And this is probability x is no less than 2. And this is probability of x is between 2 and 3. So if you get the answer for this part, then this one will be the difference between these two probability, because x is between 2 and 3. So you know the probability when x less than equal 3, and you know the probability when x greater than equal 2. So that's mean it will be the difference between these two probability. Okay. Do you have any question? Okay, so if you understand this, then you can also do part B. Part B is little tricky. So if you just know the trick, then it is easy to find the probability. Okay, part B is what is the probability that rainfall duration exceeds the mean value more than 3 standard deviation? So what is the probability that rainfall duration exceeds the mean? So that's mean probability of, so part B, probability of x, and x exceeds the mean value, so that's mean x is greater than the mean by more than 3 standard deviation. So plus 3 standard deviations means 3 times standard deviation. So that's when we are looking for the probability of x, where x is greater than mu plus 3 sigma. So we know the mean is 2.675, and for exponential distribution the mean and standard deviation are same, right? Because mean was 1 over lambda and sigma was also 1 over lambda. So we are given the mean is 2.675. So mu is equal 2.675. So that's mean sigma is also equal 2.675. So we are looking for the probability where x is greater than 2.675 plus 3 times 2.675. So we are looking for this probability. And for the second part, what is the probability that is less than? So that's mean x is less than the mean value. So that's with the mean value by more than 1 standard deviation. So what is the probability? The mean value by more than 1 standard deviation. That's what we are looking for, the probability of x less than mean by more than 1 standard deviation. That's mean plus 1 standard deviation, right? 1 times standard deviation. If it is given like this, by less than 1 standard deviation, that's mean minus 1 standard deviation. Less than 2 standard deviation means mean minus 2 standard deviation, 2 times standard deviation. So now we have to find this probability. Actually, what is the probability that it is less than the mean value by? Okay, so x is okay. Yeah. So less than the mean value by more than one standard deviation. Okay, so yeah, it is not actually probability of x. Yeah, less than mu plus, not mu plus actually. It should be mu minus sigma. Yeah, mu minus 1 times sigma, because it says mean value less than mean value. So less than mean value by one standard deviation. So it will be more than one standard deviation means one time. So x is less than this one, mu minus sigma. It will be mu minus sigma, not mu plus sigma. Yeah. Do you have any question? Okay, so if you do not have any question, then we'll move to the next one. We have 20 more minutes. Okay, consider the accompanying data on flexural strength for concrete beams of a certain types. So we are given the strength of some data. So we are given how many observations here? 1, 2, 3, 4, 5, 6, 24 plus 3. So we have total 27 observations here. So I should write down the number of observation here. So we have total n is equals to 27. Okay, so calculate a point estimate of the mean of strength for the conceptual population of all beams manufactured in this fashion. So we have to find the point estimate for mean. So what is the point estimate for mean? That's mean we have to find the estimate for mu. And we know that for the point estimate, we can use either mean, median, or mode. But usually we use mean as the point estimate for mean. We use sample mean, we use x bar. So you are basically asked to calculate x bar, and x bar is 1 over sigma of xi. And we have sigma of xi is 219.7 and n is 27. And this is 8.137. So state which estimator you used. So we used x bar here. So usually we use x bar as a point estimate for mean. Okay, part B is calculate the point estimate of the strength value that separates the weakest 50% of all such beams from the strongest 50%. So that's when we have to find the middle value. We have to find the mid value. So what is the mid value? So what are we looking for here? So what do we need to find in this case? Mid or median or mode? Yes, we have to find the, yes, you're right. We have to find the median because it is given that the value which separates the weakest 50% and the strongest 50%. So that's when we are trying to find the middle value. We are finding the median. Yes, we have to find the median. So how can we find the median? We have to rearrange the data and then you have to find the mid value. I'll recommend you to use the calculator in this case. So if you use calculator, you can easily find the median. So the median is 7.7 here. So in this case, the median is 7.7. And median is denoted by x tilde. So that's mean we used x tilde in this case. And part C is calculate a point estimate of the population standard deviation sigma. So the point estimate for sigma is the sample standard deviation, which is S. So you have to just calculate the sample standard deviation in this case, and which is 1.688. Now we need to interpret this point estimate. So we use a standard deviation to describe the spread of the data or variability of the data, not the center, not the linearity, not the biasness. So the standard deviation or variance is used to describe the spread or variability of the data. So that's why this estimate describes the spread of the data. So which estimator did you use? We used here the sample standard deviation. So that's mean we used S, the sample standard deviation. So that's mean we used S. Now calculate a point estimate of the proportion of all such beams whose flexural strength exceeds 10 megapascal MPa. So that's mean you have to find the proportion for those numbers which are more than 10. So how many numbers are there which are more than 10? So we have this is more than 10, one number, two, we have three, we have four. So we have four numbers which are more than 10 or greater than 10. So that's mean it will be 4 over 27. The proportion is 4 over 27, which is 0.148. Now in part E, calculate a point estimate of the population coefficient of variation. So that's mean you have to find the sigma over mu, estimate of sigma over mu. So how can I calculate this estimate? You have to use the estimate for sigma, which is S, the sample standard deviation, which you already have. And for mu, you have to use X bar. So that's mean it will be S over X bar. So you will just take the ratio of sample standard deviation and mean. Do you have any question? Okay. So the next one is also similar problem. Calculate the point estimate of the population mean. So that's where you have to just calculate the sample mean of this data. Then making assumption about the shape of the population distribution, calculate a point estimate of the value that separates the largest 50% of HDL levels from the smallest 50%. So that's where we are looking for the mean value. So you have to just basically find the median. So here we have total 20 observations. So the median will be, if you rearrange the data, the median will be the average of 10th and 11th observation. Okay, so the median is 46.5. Now calculate the point estimate of the population standard deviation. So that's when you have to just find the sample standard deviation. And here the sample standard deviation is 16.753. So now the last one is an HDL level of at least 60 is considered desirable as it corresponds to a significantly lower risk of heart disease. So making no assumptions about the shape of the population distribution, estimate the proportion P of the population having an HDL level of at least 60. So you have to find the proportion for those values which is at least 60. So that's mean you have to find the proportion where the values are either 60 or more than 60. So how many values do we have which are more than 60 or 60? One, this is 66, so we have one value here. This is 87, two, so this is 62, so we have three. This is 94, we have four. So the proportion is 4 over 20. The total is 20, so the proportion is 4 over 20, which is 0.2. So the proportion is 0.2. Okay, so here we have one more problem. related to point estimate. So calculate the point estimate for the mean. So that's when you have to calculate the X bar, and we used X bar in this case. And calculate the point estimate for median. So that's when you have to calculate the sample median, X tilde. And if you look at this two number, then you can see 1.3475 is the mean, and the median is also 1.3475. So that's mean they are kind of symmetric distribution. So in case of symmetric distribution, we can use either mean or median as point estimate of mu. So state which estimator you used and which estimator you might have used instead. So you can use either mean or median to estimate the population mean. So that's when you can use either X tilde or X bar because both of them are same. Okay, calculate the point estimate of the value that separates the largest 10% of the values. So that's mean actually we are finding the 90th percentile. And you know how to calculate the percentile from chapter 1. So basically you have to just calculate the 90th percentile, and which is 1.7714. So, and we used actually 90th percentile. Now estimate probability of X less than 2, the proportion of thickness, values less than 2. Okay, so here you have X is less than 2. So you can just convert this one to a standard normal distribution. And to do this, you can use the estimate of mu, that's mean X bar. And you can also estimate the estimate of sigma to find the probability. So it will be then X minus what, sorry, X less than 1.2 minus the X bar, the mean divided by sigma. And that will be the Z curve. So you have to just find the probability of Z less than that. Okay. So number 30. So I'll just go over one more problem and then I will stop. Consider a normal population distribution with the value of sigma known. What is the confidence interval? So what is the confidence level for this interval? Okay, so here the assumption is the population distribution is normal and sigma is known. When we have this assumption, then regardless of the size of the sample, we can use what type of distribution we can use in this case. Should I use Z or T? So which type of confidence interval we should use? Okay, so I got one answer. You say T. Could you please explain why should I use T? Yes, I got another answer. You said Z, yeah. So I got more votes for Z. Yes, because if you look at the assumption, then you can see this is normal population and sigma is known. So if sigma is known and X is normal, then the distribution for X bar will be always normal distribution. That's mean you can use Z interval here. So this value is 2.88 is Z alpha. So that's mean Z alpha is 2.88. So actually Z alpha over 2, not Z alpha, because this is confidence interval. So this is Z alpha over 2. So now we have to calculate alpha over 2. So this means actually this value is 2.88. Find this area, and this area will be alpha over 2. Now then you have to calculate alpha from here. Okay, so I should solve at least one problem from here. So this is 2.88, and this area is alpha over 2. So go to the Z table. Where is the table? Okay, so wait, let me pull up the Z table first. Yes, here is the Z table. So our Z score was 2.88, right? So this is 2.8, and the second digit is also 8. So it will be then here, yeah, this one, 0.9980. So the area is 0.9980. So that's mean, where is the note? Yes, here. So we have found that alpha over 2 is 1 minus 0.9980. So then you have to calculate, this is 1 minus, then you have to calculate alpha. So alpha will be 2 times this one, right? So if you calculate this one, then you will find maybe you will find 0.004, I think. Yeah, you will find 0.004. That will be the value of alpha. So if you calculate this one, then you will find alpha is equals to, I think, 0.004. So since alpha is 0.004, the confidence level will be 1 minus alpha. That's mean 1 minus 0.004. Then it will be 0.996. So the confidence level is then 99.6%. So similarly, for this one, the Z alpha over 2 is 1.43. So Z alpha over 2 is 1.43. First, you need to calculate alpha, then 1 minus alpha is the confidence level. And for part C, what value of Z alpha over 2 in the confidence interval formula below? So we are given the confidence level is 99.7%. You have to find the Z alpha over 2. So here alpha is 0.003. So alpha over 2 is 0.0015. So you have to calculate the Z score for 0.0015. Similarly, here we have confidence level is 66%. So alpha will be 1 minus 0.66. So it will be then 0.34. So alpha is 0.34. You have to calculate Z alpha over 2. So you can use the Z table or you can use calculator. So I'll stop here for today. If you have any question, you can ask me. And for the attendance, you should type present.